not be file.
Yeah, we'll discuss the questions together. So we all learn from the mistakes made, okay? So, just a second.
It's not that one. You copy file.
Okay, just a moment. I think, Janet is still not here. But so just wants to catch up. Okay, right. So let's get back to the paper. Okay, so everybody should also have a solution. Okay, so and let me go back to the paper here first. Right, so let's discuss some of these questions, okay, together. Starting with question one. Yeah, which of the, I think only very few of you get this wrong, okay, which is great, okay. So which of the following statements about group 1 metals is incorrect? So you see, reactivity of metal should increase down the group, while for halogen, it's the other way around. So you can draw this trend in here. This is how I like to remember reactivity. So the reactivity trend of group 1 and group 7. So similarly, for group 2, you have the most reactive metal down at the bottom. And for group 0, they are all unreactive. Okay, you don't need to put any kind of trend in here. So they are unreactive, all of them. Okay, so all unreactive. And that's group 0. And of course, they all have one outermost shell electron. Okay, the reactivity increases down the group. And they all react with cold water to form an alkaline solution. So the only thing wrong here is steam. Okay, they tarnish in air. That's true. Do you know what tarnishing means? What does tarnishing mean? Tarnishing means it loses its shiny luster. Can you write the equation here? Na plus O2 forms Na2O. So Na, it will give the bling bling. You see, it's shiny, a metal. But then Na2O is not as shiny. So this process of Na losing its shininess, okay, due to exposure to air, we call this tarnishing. Okay, so right now what that means, if you don't know what that is, loss of the shiny appearance due to oxidation. So the first half of statement B is actually correct, okay, but the second half is incorrect. You know all group 1 oxides are soluble, so this is wrong. Okay, so all group 1 oxides are soluble. So from this point onward, next time I want you to use another strategy. If you're unsure which is the correct answer, use method of elimination. You know the other three, they must be correct. So that means B must be wrong. Okay, so this is another strategy. Okay? So for question 2, I think not a single student get this, maybe just one or two, very few. Yeah, even fewer students got the second question wrong than the first one. So I'm not worried. But for this one, you need to first look up the atomic number of nickel and don't find the wrong number. So nickel is here. The atomic number is 28. What does atomic number equal? Number of electrons or number of protons. Okay, so therefore you can put that in. So you have 60 Ni28. This number you need to find yourself. Okay, from the periodic table. So from this, can you tell me how many protons, electrons, and neutrons are there? Proton will be 28. Electron will be also 28 because it's an atom. And finally, neutron it will be, yeah, so subtraction, 60 minus 28, 32. Okay, so this should be, you have to now find another element with also the same number of neutrons as nickel. Okay, so you have to look at, okay, so what about
160.
nickel? Okay, so nickel 28 here, it will not have the same number of neutrons, right? So this is wrong. And for zinc, can you tell me what's the atomic number of zinc? What is the atomic number of zinc? Let me look it up, okay, because I don't want to keep flipping back and forth, okay, the thing in here. So we have 30, so this is 30. So that means it has 34 neutrons. So the second one has, also 34 neutrons, which means it's not the same as 32. The third one has, so cobalt is here, 27. So it has 32 neutrons. So this is the answer. Okay? Right. What about question 3? So can you draw the line cycle here? Okay, that we discussed. Calcium carbonate, when you heat it, we did this revision before the pre-bomb, okay? So it will become CaO, okay? And this will release CO2 in the process. And CaO, when you add water to it, it will become CaOH2. And CaOH2, when you filter it, it will become lime water. So note the difference. Lime water is just the aqueous portion. Slaked lime, so this is lime water. Slaked lime is this mixture of solid plus aqueous calcium hydroxide. Okay, so this is why for the third arrow here, this is not like the addition of any chemical, but just filtration. So filtration. So finally, you put carbon dioxide back in, and you get back calcium carbonate. This is a very important cycle, as you need to remember the name of these things. Okay, so you have limestone, or chalk, or marble, yeah, and then you have quicklime. Right. So let's refer back to the question. You see lime water here, which means this is calcium hydroxide. Okay, so what, when you add water to it, will form calcium hydroxide? Yeah, what kind of substance? When you add water to it?
CaO.
CaO. It should be just CaO. You see here, we add water. So if you want to take our highlighter, adding water. So this is where we add water. So substance X must therefore be calcium oxide. So therefore you can already eliminate two answers. Okay, B and D is out. Okay. And then for Y, what do you add? Okay, if you want sulfite, what is the formula of sulfite? It's not sulfate. SO3 2 minus. Okay, so when you add sulfite or sulfur dioxide, so you can write down sulfur dioxide. When you add it to CaOH2, you will get calcium sulfite plus water. Can you describe this type of reaction? What is the nature of this reaction? We have learned a number of reactions: displacement, combustion, decomposition. What kind of reaction is this? It's neutralization. Can you identify the acid and the base in this reaction?
Acid is SO2.
SO2.
Base CaOH2.
Yeah, this is acidic, and CaOH2 is basic. And why is that? Why is this basic? Which ion inside the formula of CaOH2 indicates its basicity?
OH.
OH minus it has. And which element inside SO2 would hint at its acidic property?
SO2.
It's sulfur. Sulfur. Sulfur is a non-metal. It's a non-metal. So right now sulfur is non-metal. Non-metal oxides are generally acidic. Okay, non-metal oxides are acidic. So put down a few examples. Carbon dioxide is acidic because when you add water to it, it will form which acid? What is the name of that acid associated with CO2?
CaO3.
H2CO3, carbonic acid. Or you have also heard of sulfur dioxide. Well, this is sulfur dioxide. When you add water to it, what is the name of the acid?
X.
H2SO3.
SO3.
H2SO3. Okay, so you will see that when you add up these two, the number of O they do not add up to 4. So this can only be 3. 2 plus 1 is 3. Okay, you don't get H2SO4 here. Or in the acid rain chapter, you learned that nitrogen dioxide can react with water to form
XNO2 and XNO3.
HNO2 and HNO3. Okay, so this you learn in acid rain chapter. Okay, in the acid rain chapter. Do you notice something in common? They all have non-metals in them. C, S, N. Okay, non-metal oxides are generally acidic. So this is why I call it neutralization. Okay? And you get sulfite, calcium sulfite. Write down the formula. CaSO3. I still see a lot of students confusing sulfite with sulfate with sulfide. Okay, so write down all these three. If you think that they are the same, then you have to pay extra attention. Sulfide, sulfite, and sulfate. They are SO3 2 minus, SO4 2 minus, and S 2 minus. These two you need to memorize the charge. There's no way you can figure that out just by staring at the periodic table. But the last one, you can. You can look up the group number. Sulfur belongs to which group?
6.
Group 6, which hints at its 2 negative charge there. Okay, so making the answer C, that is. Okay, now this is a slightly harder question. Okay, than the first two. And then I'll also send you this annotated copy. Just jot down the key points. Okay. So carbon monoxide, hydrogen sulfide, and CS2 they are produced. Okay, in volcanic eruption. So mixture is analyzed. So what would be the mole ratio of SO2 and CO2? So you have a mixture of CO, H2S, and CS2. So all these gases are then analyzed by combustion in excess oxygen. So can you underline combustion in excess oxygen means you add oxygen to it. So anything with carbon in it will form carbon dioxide. Okay, anything with carbon in it will form carbon dioxide when you burn it. So you see two things with carbon in it. Okay, so it will form carbon dioxide. And anything with sulfur in it will form, what do you think is the gas? Sulfur, sulfur dioxide. So the question here is, if the ratio of CO to H2S to CS2 is 1 to 3 to 1, how much SO2 and SO2 you can get? Well, let's make them 1 mole and 3 mole and 1 mole to make it easier to understand. So because 1 mole, 3 mole, and 1 mole are in 1 to 3 to 1 ratio, right? You may as well make it 2 to 6 to 2 if you like. Okay, it doesn't matter. I will just make it 1 and 3 and 1. And this is another strategy I want to teach you all. If you don't know what these numbers are, or if you have trouble handling ratio, just make up a number. Okay, so make up numbers. Because at the end they are asking you ratio anyway, right? Okay, so now answer this simple question. How many CO2 can you possibly get from 1 mole of CO? 1 mole. But then there's another thing with C in it. So if you have 1 CS2, how many CO2 can you get out of it? 1 mole. So 1 mole from CO. Yeah, 1 mole of CO2 from CO. 1 mole of CO2 from CS2. So you can write down. You have 1 mole CO, this will give 1 mole CO2. You have 1 mole of CS2 as well. This, when burns, will give you another mole of CO2. Together, 2 moles of CO2. Now I want you to use a similar strategy. Do this for 3 mole of H2S. Ask yourself, how many mole of SO2 can you get out of 3 mole of H2S? 3. Because for each SO2 you need 1 S, right? So does it make sense that you get 3 mole of SO2? Yes. Now, this is harder. What about 1 mole of CS2? How many SO2 can you get? Be careful. Like, ask yourself how many S there are. So what is the answer? 2 mole. Can you add them up? 5. So what is the ratio of CO2 to SO2? Because it's asking for SO2 to CO2, so 5 to 2. Yeah, be careful. And in DSC, I'd like to try you even further by showing you a ratio of 2 to 5. So pick the wrong answer. Because they're asking for SO2 to CO2. SO2 first, CO2 later. So in DST, it will make it even harder by giving you another option 2 to 5. You may think, oh yeah, great, I get the answer. Well, you get straight if you pick 2 to 5. Okay? A days. This is one of the hardest questions. I think only very few of you get this right. Okay, as opposed to the previous 4. Many of you get those right. This one, only a few get this right. So, iron rusts faster in industrial area. Industrial area means they are industrial activities. So what kind of emission, what kind of acidic emission can be found in, in industries? Sulfur dioxide, right? Yeah, so can you put down the source of sulfur dioxide? So this is from power plant in coal burning. Okay? And then other areas, industrial areas might also have NOx. NOx being NO1 and NO2. Where does NOx come from? If SO2 come from power plant? NOx. So vehicles, yeah, motor vehicles. I want you to also put down how you can reduce the emission. We don't just, recognize the problem. We have to, reduce the emission. What can you do to reduce the emission of SO2? Scrubber. Okay, so this is reduced by either scrubbing, yeah, or you can just say scrubber, or flue gas desulfurization. Okay, so flue gas means the waste gas from the power plant. Desulfurization, I think this word is self-explanatory. To remove the sulfur. Okay, so they both work on the same principle. Is to wash SO2 with one chemical. Can you suggest a chemical that I can wash SO2 with to get rid of it from the flue gas? Should you use something basic or should you use something acidic to wash the SO2?
Basic.
Basic. Okay, so for example, you can write down wash with calcium hydroxide, which is a basic substance. Okay, so that's how you reduce the emission. For NOx, we use something that we install in cars to reduce its emission, called the catalytic converter. Okay, so install catalytic converter. So I think because I already made a real mock, but this will be on the mock, catalytic converter. There are 3 equations that happen, or I should say 2 equations that happen inside the catalytic converter. What are the 2 equations? What does catalytic converter remove from the waste gas?
Carbon monoxide and nitrogen monoxide.
Yes, nitrogen oxide. Write down these 2 equations. You need to memorize them. 2CO plus 2NO gives N2 plus 2CO2. These are harmful on the left. These are harmless. Well, this is not of immediate harm, okay, to you. And number 2, does anyone know the second reaction? It catalyzes.
Unburned hydrocarbons.
Its hydrocarbon will undergo more complete combustion in here. You know there are some unburned hydrocarbon.
Yes.
Yes, okay, unburned hydrocarbon that have escaped combustion. If you let this out of the motor vehicle, they will pollute the air. Okay, so therefore we need to burn it more completely. What is the catalyst present in catalytic converter?
Hydrocarbon.
It's platinum. Platinum. Okay, so this is one of the questions in the long question section. Okay, so only a few get this wrong. And for those of you who got this right, I still take out a point from you because it asks you to name and you wrote PT. PT is not a name. Platinum. So yeah, just be careful. Okay, so it's okay that we make mistakes in here, but just know that when they ask you to name it. When they ask you to label things, label it. Don't just write. Okay, yeah, because then you will not be following instruction in that case. So iron rusts faster. You know, rust depends on three things. Okay, what does rusting require? Water.
And water.
Oxygen. Say oxygen. Okay, that's why I take out 1 point from you. Okay, I may be a little bit harsh there, but if you put air has a lot of things. Okay, what is air? Okay, what called iron rust? Oxygen. And then it's accelerated by acid or salt. Okay, so rusting is accelerated by like a salt or acid. Okay, So and the last component is of course iron. You need iron. Okay, only iron rusts. Other metals do not rust. They only oxidize in air. They tarnish in air. So so rust faster in industrial area. You need to find something that is present in industrial area. There's not found in rural area. So apparently it should be like, what is it? It should be B, right?
Very well.
Yep.
Yeah, because of SO2. Okay, so you can blame it on the SO2, NOx. Okay. The next one is kind of surprising. Okay, yeah, the next one. Okay, because I got this
Easy,
question.
easy.
Okay, most of you get it. But even if you manage to name it, you might have found the wrong formula. Okay, empirical formula. So let's see how we do this. Yeah, we need to first reduce it back to the monomer. Do you remember how to turn the polymer back to the monomer?
Yeah.
Is to find the repeating unit. So can you circle the repeating unit? You see, it's like stamping stamp. You're stamping this repeating unit 3 times to get the polymer. So you just copy it on the left. And then you reduce it back into the monomer by removing the 2 bonds on the 2 sides and then just copy everything else. So you have CO2H. And yeah, you may be confused by CO2H. CO2H means COOH. Okay, so you have CH3 and H. So can you name this monomer? So name this monomer. How many carbon are there? 3, including the C in COOH. Therefore, you should call it propanoic acid. But then, let's not forget that there is a CH3 in here. So what do you call a CH3 group? Methyl. Okay, but then it's not done yet because other than a carboxyl group, there's also a CC double bond. So therefore, we should call this methylpropanoic acid. So we need to drop this and change it to EN. So you can write down that EN is addressing this part. Oic acid is addressing this part. Pro is addressing the fact that there are 3 carbons. And finally, meth is to describe the CH3. Okay? Yeah, so propanoic. Okay? And what does empirical formula mean? Is it the actual number of atoms or the simplest? Simplify, yeah, so let's do the counting. Can you help me count how many carbons there are in total here? 4. So C4. How many hydrogen?
6.
So 3, 4, yeah, 6. And then finally O2. But this is not the simplest yet. So if you pick A, you're so close. Okay, underline the word embryo. I see a lot of students picking A. Okay, which means you got the naming part right, but unfortunately you didn't see this. Okay, so write down simplest ratio of atoms. What do you call the formula with the actual number of atoms? Molecular. Okay, yeah, can you write down? This is actually not the answer because this is molecular. Okay, what do you call this type of structure showing all the bonds? Structural. So there should be 3 types of formula that you need to learn to, identify. Okay, structural shows you the bonding. Okay, empirical shows you the simplest ratio. Molecular shows you the actual number. Okay, make no mistake. Okay, right. So therefore the answer should be C. Okay. Now, calculation-based question. Okay, so I see that you guys might not want to work more on the calculation-based question. So let me show you some strategy. You have M forming an oxide with the formula M2O3. And when this M2O3 is reduced by excess CO, you should already be starting to write an equation. M2O3 plus CO. Can you tell me? If this is a redox reaction.
CO2.
Yes, and M. Yeah. Can you show me 2 arrows on this equation, on the side of this equation? Tell me what is undergoing reduction, what is undergoing oxidation, and then help me balance it. Which substance is reduced?
C.
Reduced.
M.
Is still wrong. It's M2O3. Okay? Only reactants can undergo reduction and oxidation. If you say M is reduced, no. We say M2O3, can you write this down? M2O3 is reduced. But then you can add 2M. But never say M is reduced. M did did not undergo reduction. It is merely what is formed in the reduction reaction. So similarly, can you give me another sentence for what is oxidized? CO, not CO2. Okay, so we say CO is oxidized, but depending on your light chain, you can add 2 CO2 or just skip that. So this is oxidation. Now I want you to balance it. Okay, 10 seconds.
3 on CO and 3 on CO2.
So 3 in front of CO and 3 in front of CO2, and what in front of M?
2.
2, yes, okay. Now put back the numbers. If you did not write this equation, this is why you did not get the right answer, because you did not balance the equation. Okay, so put down the first tip I want to share with you today. So tip number 3.
I just get
Write a balanced equation, especially if there's a reaction involved, like in this question. So write a balanced equation. Okay? Right, so what is the mass of N2O3? So it's 3 grams, right? So this is 3 grams. So this is known. What is not known? Okay, so we do not know what the relative atomic mass is for M. Okay, so this is 2.10 gram. You can write down. Can you tell me what is the relation between the mole of M2O3 and mole of M? 1 to 2. So normally, if you know the mass, how do you calculate the mole of something if you know the mass?
Find the mole.
Divided by mole mass, exactly. So can you write down mass divided by the molar mass of M2O3, yeah, times 2, because this is the 1 to 2 ratio, will be equal to 2.1 divided by the molar mass of M. But because the molar mass of M is not known, so that you can make it an unknown you like. Yeah, maybe let's make it A. I like to make something A. Don't make it X, because if you make it X, you're just confusing yourself with the multiplication sign. So can you tell me what is the relative atomic mass of M2O3 if I make M A? If I let A be the atomic mass of M, what is the molar mass of M2O3? Plus, yes, can you write down A or 2A plus 16 times 3? What about on the right? Just A. Okay, so now we need to just do rearrangement. Okay, yeah, this is the part you need to be extra careful. Okay, so let me shrink this a little bit so I can have enough space to write this. So you have 3, I'll just write everything in brown and black now. So 3 times 2 over 2A plus 48 equals 2.1 over A. Cross multiplication. Okay, so cross multiplication. 6A equals 4.2A plus, oh, I cannot do this in my head. Right. So 4.2A plus 48 times 2.1. So 100.8. Can you solve for A?
I have no idea. A is 55, 56.
Oh, I get exactly 56. Yeah. I think maybe just one. So get this right. Okay, if you get this, I congratulate you. Okay, but if you did not, let's learn from it. Do you see the workings here? We are first trying to find the mole of M2O3. Well, normally, if we know the molar mass, we can find the mole, like in a straight way, right? But now, because we don't know what the relative atomic mass is for M, we don't know what this guy has, okay? So we can let it be any unknown. Let's make it A. But then we know that these two substances, they must be linked by a 1 to 2 ratio. This is why I multiply this by 2. Yeah, multiply by 2 means if I know that this has, let's say, 4 mole, and that the mole ratio is 1 to 2, then this must be 8 mole. 2 times that, right? Yeah, this is the classic question. So maybe put a star here, another 2 stars here. Okay, very complicated one. Any question? No, okay. Now, the next one is on qualitative test. Okay, so you know qualitative test means you test for the presence or absence of stuff. Okay, so you have the first one here. What is compound P? When you see the word crystalline, it must be ionic. Crystalline means it has a crystal structure, okay, with sharp edges, okay? So means it's ionic with sharp edges, okay? Covalent structures, they do not have a crystalline structure. So when you warm something with NaOH, two things may happen, okay, in DMC chemistry. Number one, okay, reaction with NaOH breakdown. The first one is with some metal ions. We call this precipitation. The second is with ammonium ion, NH4+. Yeah, it will produce a gas. Okay, so the equation here is NH4 plus OH minus, reversibly reacting to form NH3 and H2O. What is the smell of NH3? Yes? Pungent. Yes, so this is a pungent gas. But pungency is not a, it does not provide you with a positive test result. Okay, so you have to further test it with what? How do you confirm that the gas is actually NH3? What is the acid-base nature of NH3? Yeah, you can finish talking English first. It's a pungent gas. But we need to further confirm it by using what kind of litmus? Is ammonia an acidic or is ammonia a basic gas? Basic. So what kind of litmus do you use to test for a basic substance?
Red.
Red. And even if you write red, you will still not get the full answer here, okay? Because it has to be
Moisture
moist. Yes, moist or moistened red litmus. Because if it were not moistened, okay, it will not turn blue, even if you are exposing it to something basic. So it has to, do you know why? That's because for ammonia to show its basic property,
Need water.
yeah, you need water. Can you see that for the reaction to go backward, meaning in this direction now, you need H2O. Without H2O, can you form OH minus from NH3? If I take out H2O, can NH3 alone provide any OH minus? No. That means it will not be able to determine red litmus if you take out the water. This is why it has to be moist. Okay? So just remember, from now on, when you use litmus paper, it must be moist, okay, for it to work. Okay? And on the left, I wanted to put down some metal ions. Okay, Mn plus NOH minus forms MOHN. Of course, that's just a general formula, and you know quite a few of these metal ions. So Mn plus can be Cu2 plus, Fe2 plus, Fe3 plus, Ag plus, Zn2 plus, Al3 plus. Oh, I lost count. Okay, so many. What else? Al, yeah, and then you have Pb2 plus. So all these metal ions, they can form a precipitate, okay? But not all of them can form a white precipitate. Can you tell me the color of this precipitate? Oh, actually I made one, because when I'm going through this with the Form 5, okay, I made a table for them. Okay, so you might as well benefit from it. It's this one. So this is the, so where is it? Just a second. Okay, you need to remember all of these. Okay, yeah, I hope you remember. So there are only a few white precipitates. So if you really have to guess white, because they are more white than they are non-white precipitate, okay? But you don't just remember this table. You have to also remember what they dissolve in. Okay? Yeah, I don't know how to put it, but you have to remember it, okay? Unfortunately, this question did not ask you for whether it will be dissolved in NaOH or what. So can you just tell me, from that brief moment you have with that page, how many of these will form white precipitate? Ag actually will form a brown precipitate. Okay, Ag2O. Okay, so you have Zn, Al, and Pb. So these will form a white precipitate. You can already narrow down your search. Magnesium is not one of them. Okay, yeah, so you have aluminum and stuff. But can you see that it forms a gas. What must this gas be?
Ammonia.
Ammonia. So can you highlight this? And then you write down ammonia. So this is a precipitate. But not many are white. Only these three can form white precipitate. Okay. So and then we have sorry. So this is not the white precipitate we are looking for, because if it has ammonium ion, the other ion must be negatively charged, right? Yeah. So you can only find a negative ion that will form a white precipitate with silver. So what does silver test for? Chloride. Okay, this is also another instance where I take away a point from you. When you are asked, okay, what does silver nitrate test for? This is chloride. This is not chlorine. When you say chlorine, it is Cl2. When you say chloride, it's Cl minus. Okay, so the suffix is important. Okay, silver nitrate, and then you should acidify silver nitrate. When you look at the long answer session, I also took away some points from some of the students because you just told me silver nitrate. You didn't say acidify silver nitrate. Why do you have to acidify it? Because you want to remove the carbonate ion. Okay, so can you put down this means acidify silver nitrate. You acidify it to remove the silver ion. Remove the carbonate ion, CO32 minus. The carbonate ion would interfere with your test, okay, by forming a white precipitate. So you need to remove them. You need to ask them to go away, okay. So therefore you have chloride here, you have ammonium here, B. That is, okay. Yeah, this is a pretty hard question. And okay, let me very quickly finish this one more. So you have copper touching zinc. First of all, which metal is more reactive? Zinc. Okay, you need to remember the metal reactivity series. Okay, it's please stop calling me a cute zebra. I like her call smart goat. Write this down if you have trouble remembering. So please stop calling me a cute. One way or the other, you need to remember it, unless you can think of a better way. Okay. So please stop calling me a cute zebra. I like her tall, smart goat. So if zinc, yeah, I know it's grammatically incorrect, but whatever. Okay. Yeah. So you have zinc and copper. So zinc and copper here. Zinc is more reactive than copper. Electron will always go from, let me finish this real quick. Electron will always flow from the more reactive metal to the less reactive metal. So therefore, C, okay, this is, okay, so electron always flow from the more to the less reactive metal. Okay, so A cannot be true because copper is lower than hydrogen, meaning copper cannot react with acid. Okay, so we'll pick up from here next time. Okay, so I'll send this annotated copy on the Google Classroom. So take a look at the answer key, okay, and learn from the mistake.
I passed the 40%. Did I actually pass it? The way to 5 stars is so long. It's like only halfway there. Why do we even do that? Wouldn't we have to learn to revise the old ones? It's good as the old ones. This is even not English over chapter. Yeah. It's just the code that we had word only. I only get 50%.